Hello everyone, welcome to this video where we're going to be talking about radical reactions and the stereochemistry of radical reactions. So when we look at a radical reaction of, let's say, a straight chain alkane, we get two products with chlorine, so it's non-selective. But notice that in one of them it's a terminal position, so no stereocenter here, but here we form a stereocenter. So in that case, we really get two possible products forming, right? We get the chlorine on a wedge and the chlorine on a dash. So which one will we get? Will there be any enantioselectivity in these? Well, the answer is no. What we'll see is a 50-50 mixture of both the R and the S enantiomers. So hopefully remember we would call this racemic. So what we're going to discuss now is why. All right, so why do we get a racemic mixture? Well, to answer the question of why, let's look at what a radical looks like. Remember that it's in a p orbital. Right, so the radical is technically shared across both. It's not just in one of the nodes. I'm just drawing it in one. But notice that all of the substituents on this central carbon are planar. This is a trigonal planar structure because of the p orbital, which means that the approach from this side and this side are equal. So we will have an equal chance of attack from the top or from the bottom, which is what gives us the racemic mixture. So keep this in mind because this is key for radical reaction. So let's just look at a couple of examples of this. First example we'll take a look at is this guy here, because this not only has implications in terms of imparting stereochemistry, right, making a racemic mixture of two new stereocenters, or a new stereocenter. It also influences stereocenters that currently exist in your system. So if we have a molecule with a stereocenter, what happens to that when we undergo a radical reaction? So we're doing this with bromine, so it's going to be selective for the most substituted system, right? So in this case, it's going to preferentially add to the tertiary carbon, which in this case has a stereocenter. We'll notice that we've now formed a quaternary stereocenter here, but this will be racemic. So we went from something that had stereochemistry or a stereochemical preference to something that has no stereochemical preference. We lose the stereocenter, or we lose stereochemical preference. So we're going to get a 50-50 mixture of both R and S in this case. Right? So you have to keep that in mind when you are doing these types of reactions. If the most substituted site is going to be the site where you are adding your halogen, which it will mostly be, if that has a stereocenter, you will end up losing that stereochemistry. So you won't get a preference for one or the other, you'll get a racemic mixture. Let's do one more example of this. So again, we'll use bromine just because it is selective. In case we'll use heat. So let's figure out where this will add and what type of products we're going to get. So notice here that we have two stereocenters on this molecule. So one of them, this one that I'll put in red here, that has no hydrogens. So we don't have to worry about losing that stereocenter or the stereochemistry at that center because there are no hydrogens to abstract, so it can't form a radical. So the one in red will stay. But the one here in blue, right, there is a hydrogen here. And that hydrogen is on the most substituted carbon with a hydrogen, which means that that is going to be the site where we are going to have our halogenation. So what we'll end up with are diastereomers, right? So notice that the carbon in red, we've maintained that stereochemistry and that stereocenter throughout the reaction. Nothing happened there, but we have two possibilities for the stereochemistry that happened to the carbon in blue, which means that we have formed diastereomers, right? And we will get a 50-50 mixture roughly of each of those. That will depend more on other things that you'll learn about later in the course. Right, so that's stereochemistry in radical reactions. When you form the radical at a stereocenter, you lose the initial stereochemistry, and you're always going to form a racemic mixture when you're installing a halogen at the site where a radical was formed. All right. With that, that's all there is for this one.